Welcome back to the deep dive. We've got a fascinating set of notes here today, all focused on metabolic health. Specifically, looking at how our bodies control blood sugar and this strategy called the glycemic index diet. Our goal really is to give you a clear, fast understanding of how certain carbs, think sucrose versus starch, affect your insulin response, and, well, how that can potentially lead down the path to conditions like type 2 diabetes. We're not just counting calories today, we're looking at sort of metabolic speed. How fast do certain foods actually hit your system? Okay, let's get into it.
Exactly. And, for anyone trying to manage their energy levels or maybe just thinking about long-term health, this stuff is really crucial. We know that diet and exercise are key for blood sugar, but today we're focusing hard on the diet part, specifically controlling the type of carbohydrate you eat.
Hmm.
And that's the whole basis for recommending a low glycemic index diet.
Right. So the sources immediately draw this really important comparison. We tend to lump carbs together, but your body reacts very differently to, say, starch compared to sucrose. Chemically, they're distinct.
They really are. And what's striking is how the data in these notes shows it. If you look at blood glucose curves, particularly after people eat a specific meal, the difference is, well, stark. Sucrose-rich foods cause these really drastic fluctuations. The blood sugar doesn't just rise, it spikes dramatically, often peaking super fast, maybe within, 45 to 60 minutes?
And that speed, that velocity you mentioned, it comes down to the chemistry, right? Sucrose, just plain old table sugar, is a disaccharide. Two simple sugars linked together. When you eat it, digestion breaks that link almost instantly. You get glucose and fructose flooding in together.
Yes, that rapid split is the key, because it breaks down so easily and the simple sugars get absorbed so quickly through the gut. Bam, you get this huge rush of glucose into the bloodstream. The system gets hit all at once.
Okay, but let's pause on that rush for a second. To really get why sucrose is problematic, we should probably contrast it with starch. The carbs in things like beans or whole grains.
Good point. Starches are polysaccharides. Big, complex chains of glucose molecules all linked together. And that complexity is exactly what a low GI diet leverages. Breaking down a starch molecule takes time. It requires multiple steps, enzymes working over potentially several hours to snip off individual glucose units. So instead of a flood, you get this slow, steady release of glucose into the blood. It avoids that immediate crisis sucrose causes. It's about the digestion time.
That makes a lot of sense. Like starch is a slow drip feed, while sucrose is just opening the floodgates.
That's a good way to put it. And that sudden flood from sucrose, that forces the body's defenses into overdrive. We know high blood sugar triggers an immediate response from the pancreas. The pancreas pumps out insulin. Insulin is like the key that unlocks your cells, letting glucose move from the blood into the cells to be used as energy. It's the main regulator, keeps things balanced.
Okay, and this is where the speed of digestion we talked about becomes so critical. The system handles a slow trickle just fine. But when blood sugar shoots up really fast, really high, like with sucrose, the whole system gets overwhelmed. So is the problem that the pancreas just can't make enough insulin that quickly? Or is it more that the cells start tuning out the insulin signal because it's all happening too fast?
That's a great question. The sources suggest it's kind of a cascade. Initially, yes, the pancreas is under immense pressure. It struggles to produce and release enough insulin fast enough to match that sharp spike. So glucose ends up lingering in the bloodstream longer than it should. But if this happens repeatedly, if you're constantly making your pancreas sprint after meals, then the second more serious problem starts. Insulin resistance.
Insulin resistance. So the cells themselves start to ignore the insulin, like they're just tired of being bombarded.
Exactly. That's a good way to think of it. Insulin resistance means your cells, muscle, fat, liver cells become less sensitive to insulin's signal. They downregulate. The insulin is there, knocking on the door, but the cell isn't really listening anymore. It's trying to protect itself from being constantly overloaded. The receptors might even get pulled inside the cell.
And if the cells ignore the insulin, the glucose can't get in. It stays high in the blood. And that chronic high blood sugar, driven by those spikes and the eventual resistance, that leads to type 2 diabetes.
Precisely. The chain reaction is pretty clear in the notes. Fast absorption, big spikes, pancreas struggles, cells become resistant, type 2 diabetes.
Okay, but we keep mentioning the solution, the low glycemic index diet. Let's make sure we define that clearly for anyone listening. What is the glycemic index, and how does choosing low GI foods actually fix this?
Right, the actionable part. The glycemic index, or GI, is basically just a ranking system for foods that contain carbohydrates. It ranks them based on how much they actually raise your blood glucose levels after you eat them, usually measured over 2 hours. Pure glucose is the benchmark, set at 100. So a low GI food that's anything ranked 55 or less is proven to cause only a slow, gradual rise in blood sugar. It avoids that big spike. High GI foods, on the other hand, rank 70 or higher. That category includes most sugary foods and drinks, but also highly refined starches, like white bread or instant mashed potatoes, that digest surprisingly quickly.
Ah, so it's not just sugar, but also how quickly even starchy foods break down.
Correct. By choosing low GI foods, you're deliberately picking things that force your body to use that slower, more complex digestion pathway we discussed. You're preventing the flood.
So going low GI is basically a strategy to stop putting that intense, sudden demand on your pancreas and your cells, giving them a chance to recover, maybe even reverse that fatigue or resistance cycle.
Absolutely. You're managing the rate of glucose entry. The sources really emphasize this metabolic cascade. Rapid absorption causes the spikes. The spikes exhaust the system and lead to resistance, and resistance paves the way for type 2 diabetes. It all traces back to the speed of digestion.
And type 2 diabetes is obviously serious, but the notes suggest the damage doesn't stop just at blood sugar control, right?
Ah.
What about the longer-term consequences of having high blood sugar all the time?
Yes, this is critical. Chronic hyperglycemia, persistently high blood glucose, is actually toxic. It damages specific tissues over time, especially blood vessels and nerves. High glucose levels cause things like oxidative stress and glycation, basically, sugar molecules sticking to proteins where they shouldn't. This damages the delicate lining of blood vessels throughout the body. Over years, this leads to major cardiovascular problems, heart disease, stroke, but it also affects the tiny blood vessels, the microvasculature.
That's where things like eye problems and kidney damage come in.
Exactly. Retinopathy, which can cause blindness, nephropathy, leading to kidney failure and the need for dialysis, and peripheral neuropathy, nerve damage.
Neuropathy sounds particularly bad.
Mm-hmm.
Pain, numbness.
Yes, and often in the feet. This nerve damage means people might not feel injuries, leading to infections, ulcers, and sometimes, tragically, amputations. So that initial issue with rapid carb digestion has these incredibly far-reaching, serious consequences system-wide.
Wow. It's quite sobering to see that connection. From eating something sweet or highly refined to potentially facing blindness or amputation years later. The food structure seems like such a small detail initially.
It does, but its cumulative metabolic impact is huge.
Yeah.
The main takeaway here isn't necessarily about banning sugar entirely, though reducing it helps. It's about understanding and managing metabolic timing. Favoring those complex carbs, the low GI choices, forces that slower, more controlled release of energy. You manage the speed, you avoid the spike, you protect the system.
That different starch structure, giving slow release, versus sucrose, giving that rapid split. That really seems to be the core lesson for you, the listener.
Mm-hmm.
And managing it starts with those conscious food choices, focusing on that low GI approach, alongside, of course, regular physical activity to help keep your cells sensitive to insulin.
It really shifts how you look at your plate, doesn't it? It's not about deprivation. It's about choosing smart, sustainable energy delivery.
Definitely. So as we wrap up this deep dive, let's leave you with a final thought to consider, based on everything we've discussed. If the simple breakdown of common table sugar, sucrose, into glucose and fructose can kickstart such a disruptive cascade, overloading your pancreas, tiring out your cells, fostering resistance, what other highly processed foods engineered for shelf life or immediate taste appeal might also be designed in a way that delivers their energy payload too quickly, unintentionally overwhelming your body's natural mechanisms for maintaining balance day after day. Something to think about next time you're reading an ingredients label.